All right. Did we read this already?
Yeah.
Great, excellent, very good. Okay, so we're going to be talking about solving logarithmic equations. What did we do yesterday?
We found the x.
We found the x, but what type of equations did we find the x in? Exponential, very good. And the first way I showed you was to do what? Not actually logs.
The base.
Same base, right? Because if the bases are the same, then we just care about the exponents, okay? If they're not able to become the same, right? You're trying to figure it out and you can't do it, like with our rewind. You can't rewrite 7 using a base of 2. All right, so what did you have to do? And in order to be able to do that, Mackenzie, you have to take the logarithm of both sides. That allows you to take this exponent and move it to the front. Okay, so those are the two ways to solve exponential equations. So now with logarithmic equations, all right, if you notice on this slide, I've given you kind of two goals, right? So make sure you're taking a look at these. Oh, that was kind of funny. Not even a little bit funny. Yeah, hashtag goals. Jeez, guys, 7:40, time to wake up. Oh, that was 2015? See, you need to tell me these things, Joel. All right, just ignore that. Okay, so these are your two goals. These are your two goals. You're trying to get one logarithm on one side of the equation. If you notice here, I've shown you this is one logarithm on one side. I'll show you why that helps you solve it. Or you're trying to get a logarithm on both sides. Okay, on both sides. So those are your options. If you don't have that, then use your properties from last Friday to do that. All right, so let's do an example together. So have I achieved one of my goals already?
No.
We'll take a look at the goals again. Yes. Have I achieved either 1 or 2? Yes, I have. Which one? 1. Okay, we have one log on one side. Right? See how there's a logarithm on this side? Is there a logarithm on the right side? There's not. So this is where I'm going to use that swoop thing. All right? And the math term for that is to write it in exponential form. Right? This is in what form right now? Log form, right? So if there's a log there, it's in log form. So if we want to write it in exponential, this is where we do the swoop thing. So start at your base. What is my base? 3, right? Log base 3. So 3 to what power? To the second power is equal to x minus 5. That's literally what I'm going to write. All right, you should know 3 squared. And then what type of equation is this? It's algebra 1, right? It's linear. So you should be able to solve that. So what is x going to be equal to? Very good. Always, always, always check to make sure this is okay. So I'm telling you right now, I'm guaranteeing you right now, when you take my quiz on this stuff, I'm going to have an answer or two that is actually not going to work. All right, it's going to make something that's not okay with a logarithm. So let's check it. What's 14 minus 5? So is this a true statement? Log base 3 of 9 equals 2. Yes, it is, because 3 squared is 9. All right, questions? Everybody okay? All right, so that's the first one, and that we achieved. We didn't have to do anything. We already achieved that first goal. One logarithm on one side. All right, these are going to be very important. All right, very important to remember those. All right, let's go to the second example. Okay. What do you see here? There's a log on both sides. So we've achieved what goal without doing anything? Actually, the second goal. Now, this is important. This is important. This only matters if your bases are the same. And is it the same here? It's not the same? The base is not the same? There's no base. So what is the base? 10. Remember, that's the common logarithm. If there's no base, it's a base of 10. If that's true, if you have a log on both sides with the same base, then the only thing I care about are these arguments. Because they must be what? They must be equal to each other. Think back to yesterday. Does that seem familiar when we had the same base? It's the same idea here. Once you have a logarithm with the same base on each side, I don't care about it. I just care about the arguments. All right, so set these, bless you, equal to each other. And again, it becomes what? Algebra 1. Right? You're going to find that a lot about the stuff that we're going to do the rest of this semester. You're going to get new concepts, all right? But it's all going to boil down to stuff that you already know how to do. All right, so solve that real quick. So I got 3. Yes, and we should check it.
It's right.
That's right, okay. So we don't need to check it?
No, I already checked it.
Oh, you already checked it, great. So we get log of what? 15 equals log of 6 plus 9 is 15. Great. So a true statement. Everybody good? Yes, Chloe.
So for the answer, you don't have to put the 10 in the base.
You don't. It's kind of like when we did the square root. What is assumed to be the index here? No, what's assumed to be this number right here, this index? Actually, not a 1. No. It's a 2, right? Because it's what type of root? It's the square root, right? Do I ever write that? No. It's assumed to be there. All right? Same thing. If you write, it's not wrong, Chloe, if you write 10, right? If you write the base of 10, it's not wrong. It's just unnecessary. All right? And your calculator can only do logarithm with base 10. All right? Do you guys remember when I showed you the change of base formula last week? No, we forgot that? I'll show you another time about how to do that. I'll show you how to do any log in your calculator. All right? Okay, last example. Do we have either of our goals achieved, 1 or 2? So finally, we have to do some work here. All right? And this is why I taught you those properties last week. Okay? What do you notice about these two logarithms? They have the same base, and how are they connected? With subtraction. So what does that mean I can do with these? You can divide what? The two arguments. And what are the two arguments? 45x and 3. So I'm going to write it as one logarithm. But what's going to be my new argument? 45x divided by 3. All right, again, remember, whenever it's subtraction, you should be writing division to connect them. All right, what if it would have been addition? Then you would multiply them. So this is those log properties we talked about last week. All right, equals 1. All right, now we can reduce that. What is 45x divided by 3? All right, so I've got the log of 15x equals 1. Now have we achieved one of those goals? Yes, which one? The first one, right? We have one log on the left side. So what can I do now? The swoop thing, right? Again, I don't mind you saying swoop, right? It's a lot of fun. Did you guys enjoy my Cheryl Swoops joke? No? Okay, never mind. Yeah, championships. Yeah, winning. All right. You need to know, though, that it's not actually technically called swoop. That's just what teachers like to say. It's easy for you to remember. It needs to be you're changing from log form to exponential form. All right? Log form to exponential form. So here we go. What's my base? There's nothing there, so it's a 10. So 10 to the first power equals 15x. So literally just write that out. 10 to the first power equals 15x. And again, as you have seen in all of these examples, it now becomes a linear equation. So all you have to do now is isolate for your variable. So what's x going to be? Right? 10/15, which reduces to 2/3. All right? Again, we should check to make sure that's okay. We should check to make sure that it works. All right, so what's 45 times 2/3?
30.
30? So I got the log of 30 minus the log of 3 equals 1. That's what it says, right? So go and do it in your calculator. What's the log of 30 minus the log of 3, and I hope you get 1. Is it close to 1? All right, close to 1. Good. You got exactly 1. All right, any questions on these? Any questions? Say it exactly 1? Yeah, you should get exactly 1. All right? All right, so we have, this is the only at your boards. So I want you guys to do all of these. Now I'm going to tell you right now, the first couple will go pretty quickly. The last one will be the hardest one. All right, the last one will take you some time, so get a chance to try that. All right, remember, try to focus on finding either the first or the second goal.